Welcome to this module of MIST 4000 Data Literacy in Business. In this module, we will be covering the following. We will start by first talking about computational analytics and what we mean by computational analytics. We will then briefly review programming languages and some concepts associated with the programming languages. We will then look at the programming language of Python and some specific features about it. And then we will jump into looking into the environment in which we are going to be writing Python code, specifically Google Colab. Lastly, we will introduce ourselves to some concepts associated in programming, specifically Python programming, associated with variables, data types, and operators. Let us start first by talking about computational analytics. What we mean by computational analytics is the use of computational approaches to deal with data problems. Now, why might one use computational approaches in this day and age? Well, several reasons. The last 15 or 20 years have been categorized as the age of big data. What this means is that some things about the nature of data have changed in the last 10 to 15 years. These typically are the velocity or the speed at which data is entering the organization, variety, the different types of data that are entering the organization, volume, the amount of data that is entering the organization, and veracity, which is the ability that we have to trust in that data, or whether we can actually trust in this. These four V's, velocity, variety, volume, and veracity, characterize this age of big data. In the good old days, we could use traditional approaches having to do with simpler algorithms and simpler technologies to analyze data that might be present in an organization. However, these four V's have exponentially and dramatically and drastically changed the nature of data that organizations have to deal with. To address this problem, organizations have to rely on technology and computational approaches to deal with data problems. And these computational approaches get applied at several different levels. Use of computation include the acquisition of data, or how an organization is able to acquire the data, bring the data into the organization and into organizational systems. For instance, there are these things known as application programming interfaces, or endpoints are one way an organization can acquire data, and one might need to write some code, write some applications, some programs, some scripts to actually connect to an API endpoint to bring data into the organization. One might also rely on approaches having to do with web scraping as another way to acquire data and bring it into the organization. One might need to connect to several different systems and several different applications present at partner, supplier, customer premises to acquire data and bring it into the organization. And so the role of computation in this is the platform or the mechanism via which data can be acquired from several different systems and brought into the organization. The next use of computation to deal with data problems is to pre-process the data or to clean the data. Most data that is acquired from external sources, and even internal sources sometimes, have a lot of issues with them. And these could be formatting issues, white space issues, these could be issues having to do with there could be a lot of errors in the data. Data that might come from different systems might represent the same information in different ways. And so there's a lot of pre-processing that needs to happen to the data before anything further is done, before it is stored in any way, shape, or form. And that typically falls under this rubric called data cleaning. Now, most data analysts spend around 70 to 80% of the time pre-processing or cleaning their data. And computation or computational approaches allow an analyst to go through this tedious task, quite tedious task, uh, pretty easily, since it allows us to take a systematized approach to data that has been acquired, data that is actually present. Uh, the next use of computation is in the storage of data and the management of that stored data. And so we can talk them kind of together. Uh, Oftentimes, data needs to be validated, data needs to be audited, data might need to be updated. Uh, and so the storage and management of data is is also a time consuming task, and it is or it can be a tedious task. Computational approaches uh, allow for the storage and management of data in a more systematized manner. And lastly, computation allows us to analyze and visualize the stored data. Um, and this could mean anything from creating dashboards, creating reports, running statistical analysis, building forecast models, and things of that nature. Uh, and so the reason we talk about computational analytics is because the nature of data has changed over the last 10, 15 years, and computation allows us uh, to use the power of technology uh, in the face of uh, this big data deluge that's coming our way. Now, when we talk about computation, how do we interact with a computational system? Well, we've got to use a language. We've got to use a programming language. And so programming languages are the way we interact with the computational system. What really languages allow us to do is to develop a set of instructions, to develop a set of uh, rules for the system to follow so that the system can aid us in the solving of a problem, right? And so what we want to do is we want to develop a set of instructions, and this set of instructions automates the system in some way, and subsequently the system, by following those sets of instructions, aids us in the solving of a problem. Um, Now, there is a lot of detail to programming languages that we're not really going to be talking about, but a couple of concepts associated with a programming language. Since there are a variety of different types of programming languages out there, here are some key ideas associated with the programming languages. Programming languages can either be high level or low level. High level or low level basically relate to how we versus the computational system interact with these instructions. A high level programming language is a language that is very similar to English, or a mode of communication that we would understand, right? And so if we had to write a set of instructions for us to interact with one another, right? A high level programming language is a language that takes these instructions and represents them in very uh, uh, native language specific terminology. That means very similar to what it might be like to communicate a set of instructions, to if we were doing it person to person with each other. Uh, On the other hand, we have low-level programming languages. And low-level programming languages are languages where the set of instructions are described in a manner that a computational system or a computer can actually understand better, right? And uh, and so in the recent for the last couple of decades, high-level programming languages are the predominant way in which we actually program instructions. Programming languages can also be compiled or interpreted. Now, compiled languages have this additional step. So when we write a set of instructions, a compiled programming languages takes that set of instructions and runs through this process known as compilation. This compilation process takes this natural language set of instructions that we can read, and it looks like English to us a little bit, and converts them into a low level language, and then that compiled code is then run on the computational system. On the other hand, an interpreted language is basically compiled during runtime, or when the computational system actually reads a set of instructions. In the reading of the instructions and executing of those instructions, that high level to low level kind of transformation takes place during runtime, as it's called. And lastly, languages can either be weakly or strongly typed. Weak or strong typing has to do with the way data is managed in the programming language. In a strongly typed programming language, every variable, and we'll talk a little bit about this later, but every variable that holds data has to have that data be of a specific type. And once we have defined what that is, it cannot be changed during runtime, for instance. On the other hand, a weakly typed language allows us to change the type of data that is stored in a variable in runtime if we choose. Right? Now, there are lots of other differences in programming languages, and there's a lot more to learn about programming language, but that is really not the goal of this module of the course. In talking about this, we want to just generally understand where programming languages are coming from. So let's talk about Python. So Python is a programming language, and it is a high-level programming language. And by that we mean the instructions that we write in Python are going to be very similar to what we might do. It's going to look familiar to us because it's very close to the natural language, to English. Python is a dynamically typed language. That means variables have no fixed type, and the type of data that can be stored in a variable can change over the course of a program. And lastly, Python is an interpreted language. That means that it's compiled at runtime. Now, there are lots of different programming approaches that one can take, and different programming languages support different programming approaches. Python supports a variety of different approaches. It supports the object-oriented approach, functional and structured programming approaches, and actually a couple of others as well. Python is highly extensible, and what this means is that while the base language of Python provides some functionality, there are extensions that we can use that provide additional functions to the Python programming languages. It allows us to extend what Python natively is capable of. For instance, there might be packages or extensions that allow us to do data visualizations. There might be packages or and extensions that allow us to do time series forecasting, or build statistical models, or to do social network analysis, and things of that nature. Now, there are multiple versions of Python over time because it's been around for a while, but the current stable release of Python is version 3.8. So, how are we going to write the Python code? Well, we're going to use an environment known as Google Colab. It's a cloud-based environment. It's freely available to us. The only thing required to use Google Colab is a Google account. And so the first thing we want to make sure is we have a Google account. Uh, and you can sign up for that for free. And so Google Colab is a cloud-based environment to write and run Python code. It allows us to create and save Python notebooks. These are very similar to Jupyter notebooks, and so if any of y'all are interested, y'all can take a look at Jupyter notebooks, and it's pretty much a Jupyter notebook. These notebooks are basically a combination of executable code or Python code along with rich text or text that might describe the code, and you'll see some examples of this. You'll see actually a lot of examples of this as we go through the module. There are a couple of components of the Colab environment. The first component is this idea of cells. And there are two types of cells in the Colab environment: text cells and code cells. Text cells are used to create markdown or are used to basically write text that describes something. It's basically, like, think about it as like taking notes, describing what the code does, writing a set of instructions, things of that nature. So it's basically it's used to create markdown syntax, and it can't be executed, right? On the other hand, there are code cells, and code cells allow you to write executable Python code, and each code cell has like a play button right next to it that can be used to run the code in the cell. And so we're going to take a look at that. For this module, which is the Introduction to Python Programming, there is a notebook available, and this notebook is hosted at a website called GitHub. You're going to find the link to where the notebook is hosted on GitHub at this location.